Hey everybody and welcome back. If it's your first time here, welcome to this channel. I'm David Townsend. This is the Net Academy where we are learning networks together. And on this video what I'm going to be going through is a continuation in the Apstra series. Specifically, this video is focusing on the concept, on the principle of designing a data center. Now, if you don't know what Apstra is from Juniper Networks, please follow this link. It's the video that I've done which describes what is Apstra, i.e. it's a data center solution, of course, but it uses something called intent-based networking. And I'm going to do a quick recap, just a minute or two's recap on what intent-based networking is in just a minute's time. But this is really important because on my EVE-NG environment, the data center, those vJunos switches, they're not powered up, they're not even onboarded onto Apstra. But Apstra, you will see, we can still design the data center. We can still design what it looks like, what it feels like, and who's connected to who. How many spines are there? How many leaf devices are there? How many servers are there? Etc. Etc. What's the intent? And that's really the concept around our intent-based networking. It's what's your intent for the data center, and then Apstra makes that a reality. So in this video, we're just going to start off with a quick recap into what is intent-based networking, just a few specific points, and then I'll show you the EVE-NG environment. I'll show you this virtual data center that I've created, and then guide you through a really quick and easy process on how to design that intent, how to design that data center based on your intent, whilst of course describing these key principles such as what is a logical device, what is an interface map, what is a rack type, what is a template. All of these things are really critical, important to understand when it comes to the Apstra solution. But for now, let's just start off with that quick recap onto what is intent-based networking. I'll then show you the EVE-NG environment, and then we'll get into the exciting stuff, which is designing that data center with Juniper Networks Apstra. Okay, so before we go into EVE-NG and before we start designing the data center, here's just a quick recap on what intent-based networking actually is. Now, for me, it's very much, what do you want the data center to look like? How do you want it to feel? How do you want it to be connected? Who do you want to be connected to where? What are the uplink speeds? What are the downlink speeds? Do you want any breakout cables? What are the routing policies? What are the security policies? There's quite a lot that obviously goes into any network, and data centers are absolutely no stranger to that. So really the intent is, I want something A, I want something B, I want something C, D, E, F, G, all the way through, That is the intent. You want the data center to be designed in a particular way, you want it to be connected in a certain way. And what Apstra is then doing is it's taking the intent, it's taking the design, it's taking that reference, and it is deploying it onto those connected devices. Now, as you can see here, there's different vendor names. There's Arista, there's Cisco, there's Dell, there's Juniper, Sonic. Apstra is a multi-vendor solution that is extremely unique. I've said that before. But coming back to the intent, regardless whether the spine devices, the spine switches be Cisco and the leaf devices be Juniper leaf devices, Apstra can work with it all. And it's taken that original intent, i.e. I want something A, I want something B, I want this routing policy, I want this security policy, and it's deploying it onto the network. And then from the network, all the telemetry is coming back up to Juniper's Apstra, and it's able to compare apples to apples as such. It's then able to see, well, I've got the intent to begin with, and I know what the network, the data center network should be connected like. I should know, and I do know, who's connected to where, and what everything is in terms of routing policies, connectivity, etc., etc. And it's then able to analyze and validate the assurance that is the intent as per what's been seen on the network. Hence comparing apples to apples. And if the two are similar, great, there's no issues, there's no errors, there's no faults. But if Apstra detects that actually a link has gone down, or transceiver's failing, or traffic is getting too high and there's lag imbalance, just for example, that's not as per the intent, and then it will flag that up and make users aware of that via something called intent-based probes. Come on to that in a few more videos time. We're going to build up to that, but this in a nutshell is what intent-based networking is. Taking your intent, what do you want the data center to look and feel like, as I always say, Apstra takes that, deploys that, that's the next video by the way, and then it validates that the intent is being met. And if you want a few more specific points as to what is intent, it could be what are the switches dash routers. Don't really use routers, that term in the data center world, it's leaves, it's spines, but how many nodes are there, how many spines are actually needed, how many leaf devices are actually needed, how many network interface cards or NICs are actually required, what are the speed of those network interface cards for both the uplink and on the downlink, what is the function of those network interface cards, and by function it's referring to, is this a network interface card, is this a port that's connecting to a spine, is it a port that's connecting to a leaf, is it a port that's connecting to an access switch, is it a port that's connecting to a firewall or external router, is it a port that's connecting to a generic server, and are there any redundancy protocols? So I'm just not go through all these points, but redundancy protocols, are you using multi-chassis lag, are you using ESI lag, or is there no form of redundancy? Not obviously ideal. What are the BGP sessions? Apstra uses eBGP for both the underlay and the overlay. This is for a particular version of Apstra known as the reference design. There's another version called Freeform where you can decide your own protocols, but we're going to be talking about the reference architect. And what are the LLDP sessions? And for the external connectivity, I mentioned external router. Do you want any external connections to an external router? What are those speeds? Where is it connecting in the network? What is the speed of it? What connections are actually going to those external connections? And as such, what is the route summarization that you might want to advertise into and out of the data center network? Do you want to do any injections, such as a default route, if you want the data center to be connected, not directly, to the internet? And then we've also got things like network isolation as well. So do you want any security policies, multi-tenancy, VIFs for separating different types of traffic, customers, users into different VIFs? Do you want to do route leaking? You can see suddenly what you want the data center to look and feel like. When you start looking at what the intent is, there's actually a lot of questions as to what you want the data center to be, how you want it to be connected, where you want it to be connected, as you can actually see. But Apstra's taken all of this builds into the intent, and then it deploys it onto the network, as I said, and it then validates in the day 2+ operations, is that intent actually being met? So that's a quick recap on what intent-based networking actually is. Now let's go on the EVNG lab. Let's get into the exciting part, and let's actually now design that data center network. But let's show you first what we are going to be designing. So here we go, everybody. This is the virtual data center in my EVNG environment that we're going to be designing on Apstra in this video. So Apstra being the AOS server here. What you're seeing in terms of this virtual data center is, of course, we've got the spines. For data center, we don't talk about terminologies such as core and access and distribution layers. No, spine, leaf terminologies. So there's two spines, spine 1, spine 2. You can also see that there's 3 leaf devices, leaf 1, leaf 2, and leaf 3. But you can also see that there's different connectivity on the leaf devices. Yes, each one has a connection to spine 1 and spine 2 via the GigE 001 and GigE 002 interfaces for each leaf to spine 1, spine 2 respectively. But you can see for leaf 1 here, it's got 3 different connections to what Apstra calls generic systems, i.e. servers. But if we look at leaf 2, it's actually only got 1 connection to an access switch, which is then providing the connectivity to those generic systems, i.e. the servers. And if you look at leaf 3, it has again only 1 connection, but that's to an external router. And this is what we're going to be designing and go through the key points in the design phase, the day zero phase on Apstra, such as what is a logical device, what is an interface map, and a little bit more. But you can also see here that there is this addressing. Let me clear up the display. There we go, that's a bit cleaner, isn't it? So you can actually see here, this is the addressing. Now this is important because the IP fabric is really the underlay. So this 10.20.30.0/24 is going to be the underlay. Apstra will use eBGP as the underlay and eBGP as the overlay, and then do eVPN signaling on top of that. So that's the underlay, and then we've got the loopback addressing, which is the overlay. That is to establish those VNI or VXLAN tunnels, and you can see the pool there. And because BGP uses autonomous system numbers, we've also got a pool here. The point being is that in Apstra you can configure what's called these resources, and when we deploy in the next video, the day one operations, when we deploy this architecture, when we deploy this data center network, Apstra just automatically carve out, assign, grab IP addresses for the underlay, grab IP addresses for the loopbacks, grab ASN numbers for the BGP routing, and just automatically assign that to spine 1, spine 2, and all the leaf devices, and keep track of who's got what IP address, ASN number, etc., and obviously do any routing policies, plus a lot more associated to it. Now, final point is that everything is turned off. Apart from Apstra, everything is turned off. The spines aren't booted up, the leaf devices aren't powered up, nothing is even onboarded onto Apstra. But this is the design that we are going to be going through, and you're going to see me coming back to this topology because I can't remember it all off the top of my head. But now let's go onto Apstra. And here we go. This is the home page on Apstra. Welcome to Juniper Apstra. Do you want to design the network? Do you want to create and deploy a blueprint? Well, let's just take it one step at a time. On the left hand side, if you've not seen this UI before, you've got what I call tabs. So under resources, we're going to spend most of our time in the design phase because this video is all about designing the data center on Apstra. So logical devices, interface maps, rack types, and templates. It's going to be the focus really of this video. But under resources is where we can build those ASN pools, those VXLAN VNI pools, the IP pools for both the underlay and the overlay. And let's actually start there with the IP pools. And of course, Apstra comes with pre-built pools for you for a data center. You can use them or you can configure your own. So if I come back to the EVNG topology, we can see the IP fabric, the underlay for eBGP peering is 10.20.30.0/24. So let's create that pool, and I'm just going to call this the IP fabric, and it's going to be 10.20.30.0/24. And I'm going to create another one because we also have the loopback addressing. That is the overlay 192.168.10.0/24. So I'm going to call this loopback overlay, and that's a 192.168.10.0/24. Let's create this, and now you can see that the IP fabric and the loopback overlay, those two pools, have been created, but they're not assigned because again nothing is powered up. We don't even have those spines and leaf devices onboarded onto Apstra, and that's why you can see the total usage is at 0% because we haven't assigned this out. We haven't deployed that fabric yet. But we also need to create the VNI pools and the BGP pools, the ASN pools. So let's go back into resources, and it's going to ASN pools, and it was 65.100 to 65.200 for the autonomous system numbers. Let's create the ASN pool here. You can see this is so straightforward. ASN pool, I'm just going to give it this name, 65.100 to 65.200. Let's create this, and that's there ready for the next video when we deploy this configuration. So that's the ASN pool, but we also need the VNI pools, which I think was 5,000 to 5,100 for the VXLAN tunnels. So let's just call this VNI 5,000 to 5,100. Create this. That's really the first part done. Quick, easy, creating your resources, and when you have your devices onboarded onto Apstra, you deploy the configuration, Apstra will just take a VNI, a BGP ASN number, a IP address, just automatically, and as I said, assign that to the devices, build the routing policies, and a lot more for you. It's all automated. But what we need to actually do is design this data center. We need to design this leaf devices connected to the spine devices, and leaf 1 being built like this, and leaf 2 being built with a connection to the access switch, and leaf 3 being built to have a connection to a firewall. So how do we go around designing a data center? Well, the first concept in designing a data center in Apstra is something called the logical device. Now, before I describe what the logical device is, just know it's an abstraction. At this point, Apstra doesn't care about the hardware vendor. As I described, Apstra is multi-vendor. It supports Juniper, of course. It supports Cisco, it supports Arista, etc., etc., etc. The logical device doesn't care. It is quite literally the building blocks of the data center design. And the Apstra comes with all of these pre-built logical devices for you. Now, as you're looking at this, I will read out. I had to write this down. There's no way I'm going to remember this. I'll read out the textbook definition from Juniper, from a training course I've done, on what a logical device is. So these are logical representations of spine, leaf, and generic systems, which are servers, external routers, and so on, i.e. the logical representation of nodes. You can configure the number of ports, the speed of these ports, and what role they have in a logical device. That means, is a logical device a spine? Is it a leaf? You do not, however, have to specify which vendor equipment you will use. That comes back to what I was saying. Apstra at this point, from a logical device perspective, doesn't care about hardware vendor. It is quite literally, what's your intent? How do you want the network to be configured? What is the role of this device? Is it a spine? Is it a leaf? And how many links does that actually need? And what are the speeds of those links, of those ports? And that's really what you're seeing here. So you could say here, AOS stands for Apstra Operating System. There's a 7 by 10 spine. So that means that there's 7 10 gig links. 5 10 gig links connect to a super spine or a leaf. And then there's 2 by 10 gig links which connect to a generic system. That's Apstra's terminology for a server or an external router. And there's a lot more. You could see AOS with all these connections here and these ports and these speeds, 100 gig, 10 gig, 1 gig, and it gets more and more and more. We're obviously going to build our own logical devices because our intent, coming back to EVNG, is that Spine 1 and Spine 2 have 3 1 gig connections, Gigi 1, 2 and 3, to Leaf 1, Leaf 2, Leaf 3 respectively. But then Leaf 1 and Leaf 2 and Leaf 3 are using the same uplink ports to go to Spine 1, Spine 2, but then you can see that the intent is to have Leaf 1 and Leaf 2, Leaf 3 with different downlink interfaces in terms of who they're actually connecting to and what port they're actually using. So there's a different intent there. But we don't care. This could be Arista, this could be Cisco, it could be Juniper. It doesn't matter. But coming back to Juniper Apstra, we create a logical device, obviously under this icon here. And I'm going to start off with the spine devices. I'm just going to call it Spine LD for logical device. And there's this panel. You can have X amount of panels. As long as the hardware vendor supports this, it will tie back to a hardware vendor at some point. But right here, you just define what is your intent, what do you actually need. So for the spine logical devices, we only need 3 1 gig connections which are going or connecting to leaf devices. And that's it. You can add another panel, as I said. So if the spine devices had 2 connections which were 10 gig going to a super spine, I could create that there, but as per my intent. But obviously the spines do not have a super spine connection yet. That might be in a later video. And actually I'm going to leave that in there because it's probably good practice to do so. So that's already there created for my future intent. But let's create this and we can actually search for this. And let's just do spine. And you can see it all the way down at the bottom here. Here's a spine logical device. And I just want to change panel 1 to be 1 gig connection. So I can easily go back and just update the group panel, and it's just hit update, and there we go. So very easy to do, but we now need to create the logical device for leaf 1. So I'm going to call it leaf 1 logical device. It has got 2 uplink 1 gig connections to the spines. So we're just going to create a port group for that, and there we go. There's the port group to connect to those 2 spines. But we also have got 3, referring back to EVE-NG, there's 3 downlink interfaces, Gigi 4, 5 and 6, to 3 different servers. So that's 3 1 gig connections, and note here you've got all these different speeds as well, so it can go very, very fast. 800 gig, I mean, God, that's just so fast, isn't it? Side topic, but that's just incredibly fast. But these are connecting to generic systems, i.e. servers. That's Apstra's terminology once again. And that's it. That is the logical device created for leaf 1. But we now need to create the logical device for leaf 2. So let's call this leaf 2 logical device. And again, we have got 2 uplinks, 1 gig uplinks to the spine devices. Let's just create that port group. Let's add a panel. And now we've only got 1 downlink, the Gigi 000 interface going to the access switch. So we only now need 1 interface, 1 gig interface connecting to an access switch. There we go. That's the logical device created for leaf 2. And final one, let's create the logical device for leaf 3. As per the other 2 leaf devices, there is 2 uplinks going to spine devices, and there's also a second panel with a 1 gig connection going to an external router which falls under the generic system here. And that's it. That is our logical devices created. I can search for these, and right down at the bottom you can see leaf 1, leaf 2, leaf 3, and here is my actual intent. Again, logical devices is all about abstraction. What is your intent? How many ports do you need? What are the speeds of those ports, and who are they connecting to? There is then this concept of interface maps. The interface map on the right hand side, you can see it references a logical device, but then it ties it, it maps it to a device profile, and the device profile lists that hardware vendor, that model, and quite a bit more information. So if I just show you this Arista 7050QX32, this switch, you can see this is the amount of ports it supports. It's a physical device for the data center. This is the device name. It comes from Arista. This is the model. This is the OS, the operating system family. Version is a wildcard. And these are the hardware and software capabilities of it. And then you can see it supports 32 by 40 gig interfaces and 96 by 10 gig interfaces. So quite a lot. And there are huge amounts of, you can see there's 295 different interface maps that are pre-built on Apstra for you. You can create your own. But when you've got your logical device, you've defined your intent, you build the interface map to say, this needs to be a Cisco, this needs to be an Arista, this needs to be a Juniper. And that's important because when you then deploy the data center, you deploy the configuration in day 1, which is the next video I'm going to be doing, Apstra knows, I need to speak Juniper Junos, or I need to speak Cisco IOS, or Arista EOS, whatever the operating system name is, EOS. It just knows. So the interface map is very important because we take the intent and then we map it to a hardware vendor, model, and the syntax to actually use. Now, a logical device, without going too complicated, can be mapped to multiple device profiles. Why is that possible? Well, if you look at it from a spine's perspective, there's 3 1 gig interfaces. That's not very hard to do. A lot of hardware vendors can do 3 1 gig interfaces. And that is why I said, and Apstra supports a logical device being mapped to Cisco, to Arista, to Juniper models. Because 3 1 gig interfaces is easy to do, as I said. But let's create our own interface map. And now I want to reference the spine device. So here's the spine logical device I've already built. And you can already see it's saying, well, there's interfaces going to leaf devices, 3 of those. and there's two, for future video, two interfaces going to a super spine. But let's just reference the device profile. So those devices are all vJunos in my EVE-NG environment. And I'm just going to give this the name of spine interface map. And now we select the interfaces that we are going to be using when we deploy this configuration. So I just know that for the spines it's GigE 1, 2 and 3, to leaf 1, 2 and 3 respectively. So it's just a case of selecting the actual interfaces, and you can now see that's gone green, and then selecting the super spine connections, which aren't there yet. That will be for a future video, but I'll do 4 and 5 for obvious reasons. And that's it. That is our interface map created for the logical device. I can then do create another, and this will be for leaf 1 logical device. This is again going to go to vJunos with that device profile, and let's just call it leaf 1 interface map. And we've got the two uplinks, sorry, to the spine devices, which is the GigE 1 and GigE 2 interfaces. And for the generic systems, that was for leaf 1, GigE 4, 5 and 6. So let's select GigEs 4, 5 and 6. And that's it. Everything is green. Everything is checked out. Let's do the same for leaf 2. So let's search for leaf 2 logical device. This is again go to vJunos. That's the logical device I'm using in the EVE-NG. Let's call it leaf 2 interface map. The interfaces to the spines are again GigE 1, GigE 2, and going to the generic system, not the generic system, to the access layer switch. I think it was GigE 000. Yeah, here it is right here, GigE 000. And let's select that interface, GigE 0, and that is it. We can now create the final interface map, and this is for the leaf 3 logical device. Again, of course, vJunos. Those are the switches in my EVE-NG. Leaf 3 interface map. The interfaces to the spines, GigE 1, GigE 2, and going to the generic system, which is the external router, is GigE 000. So let's just select that interface, hit create, and that is it. So if I just do a quick search on leaf devices, here are those 3 logical devices. I can't see leaf 3, but I will check that. But here's leaf 1, leaf 2. Here, let's search for leaf 3. There we go. So yeah, leaf 3 interface map, logical device. And if I just reference the vJunos switch, and you can download vJunos for free, by the way, on the Juniper downloads page. It's really good operating system, really good virtual image to use. You can see it supports a lot of ports from Juniper, of course. This is the hardware capabilities. I don't know why it's listed in that. It's virtual software capabilities, and it supports 96 1 gig interfaces. That's why I'm doing 1 gig connections and not 10 gig connections. But that's really the logical devices defined, where you define your intent. The interface maps is where it takes the logical device and maps it to a hardware vendor and model. And now we start building and designing the data center, because the logical devices, as I said, are the building blocks, like pieces of Lego. Lots of pieces of Lego coming together to build something absolutely exciting. So rack types. Under rack types is where we design the racks, i.e. the top of rack switch. How many top of rack switches are there? So 1, 2, 3. Are they connected to access switches? Are they connected to servers? Do they have redundancy like multi-chassis lag, like ESI lag, etc.? And just to show you an example, and again, Apstra just has 21 pre-built for you, but we're going to build our own. If I show, let's just pick any one at random. Let's do layer 2 access compute. I have no idea what this, wow, that's quite a lot. So that is one leaf device with no access switches, but connecting to 40 different generic systems. So yeah, that's quite a lot there, and you can actually see by scrolling down the logical structure. So the rack type is called layer 2 compute. The logical device is an AOS 48 by 10, and the logical devices, the servers are AOS 1 by 10, and that's actually a Cisco. So that logical device is mapped to a Cisco switch. So that's pretty interesting. Let's show another one, because honestly I was surprised by that one. So MC lag compute. And there we go, so pretty much the same, but now with two different leaf devices running, multi-chassis lag. You could see the peering, the link between them. You could do all of this on Apstra, and scroll further down, you get the logical devices, so that's Cisco once again, and the leaf devices support 4x10 and 2x40 gig connections. This is what we're going to design. This is where you build the rack. So we're going to build a rack for leaf 1. So let's call this leaf 1 rack type, and you define is it stage 3 or stage 5 or collapsed. Actually, we don't define here if it's stage 5, that's in the template, that's the next step really. But here's it stage 3 or is it collapse? In the enterprise that would be a collapsed core. We don't have a collapsed core, this is stage 3, it's clause 3 network. So what we do is just leave that as is, and now scrolling down we define what are the leaves we want to use, how many of them, are there any access switches, and are there any generic systems. So let's call this leaf 1, and you can see it's building out the topology on the right hand side. And under logical device, if I just search for leaf 1, here it is right there, and all the different leaves actually, leaf 1 logical device. And you can easily say, well, is there any redundancy? So if I select ESI lag, oh, suddenly there's two leaves, and every access switch or generic system could then have redundancy using ESI lag to connect to these two different leaf devices. But there's no redundancy in my EVE-NG environment. I'm trying to keep it as simple as possible, to be honest. And the tags allows you to basically tag this rack, this leaf device, with a particular tag, so you can troubleshoot it when it's deployed. I haven't created these tags, these are just pre-built for you, so I'm not going to do that just yet, but you can add in a new leaf and you can configure this with its own redundancy. So it's very, very scalable, to say the least. But this is our leaf device using this logical device, and it has 3 generic systems connected to it. So let's just select generic system count 1, 2, 3. You can see again it's building out the topology. Let's just call it server, and then it does 1, 2, 3 for me. And this needs to be an AOS 1x1 gig. And tags, these are bare metal servers. There we go. And I need to add the link. You can see it's added the links between the servers and the leaf devices. Let's call this link to server. Is there any lag, a lag P going between the servers and the leaf devices? There is not. And I will give this another tag of bare metal server for troubleshooting. But that is the rack type 1 defined. Leaf 1 connected to 3 different servers, and that does represent what we're seeing on the leaf 1, which would have its own different rack as such, be a top of rack switch connected to 3 different servers, and that logical device has already been built to have 2 uplinks to spine 1 and to spine 2. Now, if I got it right, I should be able to do create other. So there we go, I'm just moving my camera out the way. So let's do create another, and that was successful. So let's now create the leaf 2 rack type, and let's give a name of leaf 2. The logical device is leaf 2 again, the logical device being the abstraction. No redundancy. There's no extra leaf in this rack. We do have an access switch. So now let's configure the name, the access switch. How many access switches do you need? You can see you can easily scale this out, but we only have the one. What is the logical device of this access switch? I've done a bit of testing on this, obviously, and I just know that I need to have a bit of a beefier access layer switch just for this virtual environment. So I'm going to select this one there. And a big point to note is that the Apstra is not managing these access layer switches or the external router, firewalls, or even the servers. It's just designing the data center so you can get more telemetry from those connections, and it just understands the connectivity. So it is important to do, that's why you have to do it. And let's add the logical link. So let's just call this link to leaf, and the link speed is 1 gig, and there's not a tag pre-built for it, so I will leave that blank. But we can see under leaf 2, connected to the access layer switch, gigi 456 goes to those servers connected to it. So we do need to create a generic system group for those servers. Server 1, 2, 3. There's our 3 servers. The logical device is a 1x1 connection. Let's give it a tag of bare metal servers. Let's add the link to access switch. And we can also now define, is it connecting straight to the leaf devices? You can see those server 1, 2, 3 has a connection to the leaf device bypassing the access layer switch, or does it have a connection to the access switch? And now it does. And are there any tags? Let's give it a bare metal server tag. And that's it. That is our rack type 2 actually defined, built. Pretty straightforward, I think. So let's now just create the final one. Let's just do create another, hit create. This is the final one, and let's call this leaf 3 RT for rack type. And back to the leaf devices, leaf 3 logical device is the leaf 3, which we've already built. See, it's just referencing it here. There's no redundancy. We are connecting to a generic system, which is on leaf 3 and a firewall. It's a virtual SRX. And this will be the generic system, so I'm going to call it firewall. Only one logical device, 1x1 connection. Tag firewall. Let's add the link. Let's just call this link to firewall. And that should be it. If I now just move my face once again and select create, and I missed something, so notice on leaves it's saying there's an error. So, I thought I'd done that. So let's select leaf 3. Logical device, there we go. Can I do it now? Yeah, so I missed that out. But I can obviously now just search for those rack types, and there we go. There's leaf 1, leaf 2, leaf 3, the rack types referencing, it's a stage 3 or clause 3 network, and it has one leaf in each rack. There's no access switch in leaf 1, leaf 2, leaf 3, but there is for leaf 2 or the rack type for leaf 2, and there is some generic system counts as well. You can obviously modify this as you go on and even as it's deployed. That is the rack types. Where do the spines come into it? Because we've defined the logical devices for spines, they've got three 1 gig downlinks to 3 different leaf devices, and we built the racks to say, well, leaf 1 is connected to 3 servers and leaf 2 is connected to an access switch, which is connected to leaf to 3 servers, etc. But how do you define the overall topology that you're seeing here? That is where the template comes into it. And again, the template, you've got your pre-built templates for you in Apstra. Let's just have a look at layer 2 pod, L2 pod, multi-chassis lag. This is where we take those racks and we define how many racks you want, what are those rack types, and how many spines you actually need. And is this a clause 5 or a pod-based network where you've got super spines? So this looks pretty interesting, but let's just show you another one. So let's just pick a layer 2 virtual EVPN. So yeah, here's 4, look like they're the same, 4 racks of the same rack type connecting to spine 1 and spine 2. We can see the links of how they're connecting as well. And if you scroll down, you get again the logical structure. So it's using Sonic and Cisco and Arista and Juniper. So that's a big mix actually on this EVPN. So that's actually pretty cool. That's bringing the theory into practice here. So yeah, that's pretty cool. But let's go back to the templates and let's now create our own template. And let's just call this Netcademy. It is rack based. It's a clause 3. If it was a super spine, it would be pod based. If it was collapsed, I'd select collapsed, of course, but we're using racks. We're not doing pod based, i.e. super spines yet in this video. Under policies, you define the ASN allocation scheme, unique or single. Unique meaning for clause 3, for rack based, every spine will get its own unique BGP number. Under single, what that means, that is for 5 stations. When there's super spines, it means each spine in the same pod will have the same autonomous system number. We're not doing pods, we're not doing super spines, so we can leave this set to unique. But if I scroll further down here under rack types is where you import the rack types that we just built. So if I add in 3 rack types here, and it's just a case of searching for your intended rack type. So here's leaf 1 rack type. That is exactly what we just built. We also need the leaf 2 rack type. Note it's just adding it in here. And we also need the leaf 3 rack type. There we go. Leaf 1, leaf 2, leaf 3. Doesn't that look pretty much the same as what there is in EVE-NG? The only difference being is that there's 2 spines here, but on the Apstra it's only showing 1. You could change that very easily, of course, under the logical device for spine. Let's just search for the spine logical device that we already built and say, well, we need 2 spines, and there we go. That is literally us designing the architecture, the look and feel of our virtual, in this case, data center. You can even say, well, I need this amount of rack types of leaf 2 rack type, or this amount of the leaf 1 rack type. You can see it's just scaling it out. Obviously, that's not the case here, but just to show you how quick and easy it is. And you can also define, do you have any links to super spines? We don't at this point. Really, that's it. We've designed our data center, spine 1, spine 2, 3 different rack types and who's connected to who. Again, the logical devices are the building blocks of this. So let's now create this, create it successfully. Now to bring this into a blueprint, just go to blueprint. Let's create the blueprint. The blueprint being is Apstra managing a data center, basically. So you have a blueprint to manage a particular data center. You can use data set reference design data center. That's traditional, what we refer to as Apstra, or freeform, which is where you can use your own underlay routing protocols and your own topologies. And I'm just going to call this Net Academy Blueprint, or BP for short. I just want to search for rack-based templates, and let's just search for Net Academy. There we go, and scroll to the bottom. This is the rack type. So this is just everything we've just defined. You can see the logical structure where it's bringing everything together. And now if I create this, it's then going to build this blueprint, but not deploy it, because again, everything is turned off. But I've still designed the data center and I've still designed my intent. So you can build all of this before anything is onboarded. But here's my blueprint created for me. Obviously there's some build errors and uncommitted changes because it's not working at this point because there's nothing onboarded, as I keep saying. But just to show you the UI very quickly, here is the dashboard. Nothing to show because, yep, the data center is not turned on. Analytics, nothing to show because it's not turned on. But under staged is the topology we just built. This is where you stage the configurations, i.e. you build the configuration for deployment. That is the next video. So there we go, everybody. That is the end of this video. That is the end of this part in this series on Juniper Networks Apstra. As always, I hope you found that useful. Hope you found that informative. Gone through quite a bit more information, but it's all been focused around the day 0 operations, which is really just about designing the data center, taking your intent and making it in this case, a virtual reality. But just in recap, we went through what is intent-based networking, i.e. taking your intent, what you want it to look and feel like. And then in the Apstra environment, we created those logical devices, which are the building blocks on Apstra. That is your intent. What are the speeds? Who's connected to who? And we did that for the spines and the leaf devices. And then we created the interface maps, because don't forget, where Apstra is multi-vendor, the logical devices doesn't care about what that actual physical hardware is at that point. As the interface maps does, it takes that logical device and it maps it to a hardware vendor and a model, and it just knows what that syntax is when it comes to deployment, when it comes to the day 1 operations. And then we built the rack types, which is when we've got the rack with those top of rack switches, with the generic systems, the servers, the firewalls, the routers, the access switches. There's a huge amount of different options you could do there, and even with different levels of redundancy, MC lag, ESI lag, etc. And then we took the template where we imported those 3 racks that we created, those 3 different rack types with our 2 spine devices, and then we imported that into our blueprint, which is really just the point of reference for managing, deploying and assuring that data center. And that is the next video, day 1 operations. So I hope you found that useful. Hope you found that informative. If you like my content, please give me a thumbs up. It's the best way to support my channel. Any questions or comments, let me know down in the comments box. I love hearing from you all. Other than that, thanks for watching and goodbye.